Good morning to the professors. I am Tanmay Mohanty, roll number 20ME10086, section 1. Here I am with my solution of the Arduino motor problem. I have opened the sample project of Arduino motor shield, and here is the Arduino board. As you can see, it is the H bridge motor driver. I am going to explain you what is an H bridge. The H bridge has 4 switches, 2 of which work in unison. When two switches which are diagonal to each other are open, it is clockwise, and for the other configuration it is anti-clockwise. It helps us to control the direction of the motor rotation in clockwise or anti-clockwise direction. Next, I am going to show you what is PWM technique. It helps since the signals are only at high or low level, to make an average between both of them. We switch it on for some percentage of time. For example, if we switch it on for 50%, the average would be 2.5 voltage. Now I am going to show you the source code. The main principle working here is that the PWM voltage or the average voltage is directly proportional to the speed of the motor. Here I have kept the 12th pin, which is the input one, and the break at 8th pin. Here, as you can see, we are using the channel A motor, and input 1, input 2 and enable A are used to control that motor. Input 1 is connected to IO4, which is connected to IO6, and the input 2 through the XNOR gate is connected to a pin. Here the main signal would be outputted at pin 6. Here you can see, as the PWM I have initialized to 100, the average voltage would be 100 divided by 255, since there are 255 PWM values in total, into the maximum voltage, that is 5 volts here. I have calculated it and it comes roughly near 1.96 volts. Now I am going to build the project, and it is compiled successfully. Now let's go to the simulation. The XNOR logic gate has a very simple logic that if both the inputs are same, it is going to give out 1, and if both the inputs are different, it is going to give out 0. It would take a little time to settle, and here as you can see, it has settled near to 9.23 to 9.24. We have used the PWM value 100, and now I am going to experiment by keeping the PWM value at 200. By keeping the PWM value to 200, the average voltage now becomes 3.92. Now I am going to rebuild the project, and it is going to be compiled successfully. Let us go to the schematic capture. On running the simulation, it would take some time and settle at a certain value. Here, as you can see, it has settled at nearly 34.6 value. Ideally, it should be double of the previous case, near 18, but since the motor rotation depends on many other variables, we therefore normally prefer the closed loop. Thank you.